So this video is going to cover the properties of logs as well as expanding and condensing. So I have just written the three properties we have: product, quotient, power. Product, of course, deals with the multiplication. And remember, your multiplication goes with addition. Quotient is the division or a fraction, and that goes with subtraction. And then your power, what you have is you have an exponent of x or a number or something, and all it does is come out to the front to now give you the second part. So I'm going to briefly talk about the difference between expanding and condensing. So when you are expanding, you have one log, and in your answer, you want to have multiple logs. So we're actually going from small to big for expanding. For condensing, what you have is you have multiple logs, and we want you to have just one log. So it's the opposite, where we're starting big and we're getting small. So you need to make sure you know the difference between expanding and condensing. You can see it in the problems as well. So on number 1, I'm asking to expand the following. So I'm going from one log and I want multiple logs in the answer. When I look at this, I see that I have a fraction. So I know for sure I'm using the quotient. So I'm actually going to kind of color code this, and I have the top part as well as the bottom part. So because there are two parts, that tells me I'm going to have two logs in my answer. So I have log base 10 of something, and I'm going to have another log base 10 of something. It keeps the exact same base that it has from the original problem. Because it is a quotient rule, I know that there's going to be a subtraction in the middle. When I see a fraction, I automatically think subtraction. Now what's going to happen is I'm taking this top part, and it's going in the first log, and the bottom part is going to the second. So I have log base 10 of 4b minus log base 10 of 7. And you've expanded. You are now done. If you're not sure if you're done, you want to check again. You want to see if there's anything being multiplied together like x and y. You want to see if there's any exponent. So like if it was like 4b squared, then you would move the exponent. But because there's none of that here, we just stop where we're at. Number 2 is very similar to the first one. So I take the log base 3 of the top 5 minus log base 3 of the bottom, which is x to the 4th. I again want to check. When I look at this first part, I just have log base 3 of 5. I can't do anything else with that. If it's just a number, you're done. Now, I can do something else with this second part, though, and it's what I was talking about on number 1. If you notice, there is an exponent here. So this also follows that power rule. We are going to take that exponent we have, and it's going to go in front of the one log that it's touching. It does not go in front of everything. So log base 3 of 5 stays the exact same. But I now have minus 4 log base 3 of x. So it only goes with that one log. 3 is literally the exact same as 2, so I'm just going to work through it again. I have log base 4 of 6, but we are not subtracting. We have them stuck together by multiplication. So remember, your multiplication means you have a plus sign. I have log base 4 of z cubed, but be careful, you're not done because of this one exponent. The exponent goes to the log directly that it's touching. So now log base 4 of 6 plus 3 log base 4 of z. So the difference is between 1 and 2, we are now no fractions, so that means we're multiplying, which means we have addition. So number 4 has a couple of different ways to do it. The way that I want to do it is I want to follow some of our original exponent rules, and I'm going to distribute this 4 in first. So when I do that, I end up with log base 2 of x to the 4th, y to the 12th. Now I have something being multiplied, so I have this first part, which is x to the 4th, and the second part, which is y to the 12th. So that means I'm going to have two logs in my answer. So I have log base 2 of something, log base 2 of something. Since they're being multiplied, we are going to be adding. I'm going to take this first part, x to the 4th, and it's going to go with my first log, and y to the 12th is going to go with my second one. So I have log base 2 of x to the 4th plus log base 2 of y to the 12th. Again, we are not done because of these exponents we have, and they both actually have exponents. So what's going to happen is the exponent is going to go in front of the one log that it's touching. When I do that, my first part is now 4 log base 2 of x plus 12 log base 2 of y. And you're done. You don't do anything else with this. There's no solving. There's no finding a final answer because this is your final answer. Now, those 4 examples we just did were all about expanding. We were going from one log to multiple logs. We're now going to be condensing. So we are going from multiple logs to one log. The first thing we need to look at is what operation there is. So we look here and there's addition. So that tells me my final answer is going to be multiplication. I also want to check to make sure the logs have the same bases. When I look here, I have a log base 4 and a log base 4, so that means they can be combined. If they do not have the same bases, we cannot combine them. So I'm going to take that common log with its base, so log base 4. I'm going to take the first piece, so this is the first piece, 7, times the second piece, which is the second log, 5. And you can leave your answer just like this, log base 4 of 7 times 5. I went from multiple logs to one log in my answer, so I'm done. This one is a little bit tricky, but you kind of have to think back to your PIMDAS stuff. We always want to start with what's in parentheses. So I'm actually going to combine these 2 logs together. I've checked that the bases are the same. So I am going to drop down the log with the common base. So log base 10 of, and it is 20, since it's addition, times 4. Now I still have that 3 on the outside. And remember, our power rule says that if we have an exponent up here, we bring it to the front. Well, it works the same way. Since we have a number up front, we're going to take it to the exponent. So I'm now going to have log base 10 of 20 times 4 to the third. If you combine 20 times 4 and make it into 80, that's totally fine. That's up to you. That's your choice. Number 7, we want to check that the bases are the same. So when I look here, I have log base 7 and log base 7, so we're good. We also pay attention that we have a subtraction sign, so that means I'm going to have division or a fraction. I need to go first backwards order. I want to see if I can change anything into exponents. And if you look here, both of these logs have numbers in front. So we're going to take those numbers and bring them up as exponents. So I now have log base 7 of 5 to the third minus log base 7 of 8 to the 15th. Since they have the same log base, I'm going to bring that down. So I have log base 7. But I'm now going to take these 2 pieces, 5 to the third and 8 to the 15th, and I'm going to turn them into a fraction. So the top of the fraction is 5 to the third over the bottom of the fraction is that second piece, 8 to the 15th. You don't have to do anything else with this. You leave it as is. And number 8 is very similar to the one we just did, but instead of having numbers, we have letters this time. So I'm taking those front 2 numbers first, and I'm turning them into exponents. We always check for those. When I do that, I end up with log base 4 of x squared minus log base 4 of y to the 6th. I have the same log with the same base, so I do log base 4 of what goes on top is x squared over y to the 6th. Can't do anything else, so you are now done.